Thank you, Riaz, and thank you
Thank
for
you.
having me, and thank you for everyone to join this session as well. I know it's a Sunday evening for you guys, so let's do keep it this way. So I'll focus more on the industry part, basically the challenges, some of the challenges you might face while using not necessarily only language models, but in general AI or ML systems as well. So because this always these things go hand in hand together. So I'll every now and then there is some part of theory as well I'll cover, but on a very high level, and we'll discuss more about the industry challenges as well, because this is something which you will never or mostly never see in textbooks especially. So, and each and every use case, at least from my experience, is unique, and each has its own nitty-gritty challenges as well. So we'll see along the line how that can be addressed, or at least we can have certain guardrails to move ahead in such cases as well. Okay. So today we'll discuss a little bit on what is language models in general, basically the fundamentals, and some working principles about LLMs, some history about LLMs and how that has evolved over time. And then we'll also see some of the basic applications from LLM. So here I'll also discuss couple of cloud infrastructure as well. So one is Azure from Microsoft, and then from Google Cloud Platform. So we'll see some of the use cases, especially which can be implemented based on the current, I would say, infrastructure available with these tech giants or cloud service providers. And lastly, we'll see some of the capabilities currently we have as an open source infrastructure or software platforms, where you will have the feasibility or facility to run language models from your local machine as well. So this especially helps when you don't want your data to leave outside or basically go out in public internet. Okay, so that's something we will discuss about today. Okay. So before we go into details of what is a large language model, because we'll also see what each and every component means. So you can see a simple Venn diagram over the screen here, so which simply tells what is the broad area and where especially the large language models fit in. Okay, so currently the hype is too high for generative AI and large language models. It might look like these components or these LLMs form the larger component of the entire AI cycle or entire AI spectrum. So that is how the current market trend and hype has been created, but in reality, if you see, LLMs are a small component of the entire AI spectrum, and it overlaps with some of NLP as well as AI, and then also computer science techniques as well. So it's kind of a mix of multiple different areas, and we'll see how that is going, or that is being evolved over a period of time. Okay. So just recently, we'll before getting into details, we'll see some of the top models, which was state-of-the-art models, you can say, which has been released very recently. One by Meta, so Llama 3, which is one of the open source models which can be used both for academic as well as for commercial purpose, and one of the most preferred models by industry as well. The reason being these models or Llama 3 models can be completely downloaded into your own environment. So basically, you can download this model, run it in your system without your data leaving your system. So that is one area where it helps in data privacy and security. So that's why most industries where there are very high regulations, where the data cannot go out of their company or organization firewalls, Llama is one of the preferred models, and also it performs quite well in almost literally most of the text generation as well as summarization tasks. Okay, and we'll see the other one is GPT-4 Omni, so which is a recent release by OpenAI. This is one of the best models they have released as well, comparatively faster and also more, mm, I would say brilliant than the earlier models as well. It has the capability to do even data analysis from any form of data structure. So be it a table, be it a document, or be text. So whatever it is, GPT-4 Omni has the capability to summarize things. Okay, so basically it is a multimodal large language model, can take in input in any form and then give you an output in form of a text. Okay, so the last one, just a few days back in the Google I/O the developers meet, we have Gemini 1.5 Pro, which was released recently, which is again a multimodal uh, I would say large language model, and Google has also expanded their tokens. Tokens in the sense the amount of text you can give as an input and also receive as an output from these large language models. They have increased it to almost 2 million. So 2 million tokens, roughly you can assume these are 2 million words. Okay, so it's quite a large amount of input can be given. So basically, you can even give an entire, maybe in your master's or UG dissertation itself and get a summarization. So it's quite flexible in terms of input and output. Okay. So now we'll see a little bit around the evolution of how these large language models have evolved over a period of time. So of course, the beginning is natural language processing. So where you can see how this models or basically what happened in this stage was people wanted to understand or use machines to understand human language. So basically, we'll try to interpret how to interpret a human language is what was initially handled through NLP techniques. So let's say what is a verb, what is a noun, how a sentence is formed. So all these kind of things is what will primarily analyzed or researched in the NLP phase. And then slightly moving towards the next phase, kind of an, you can say, a mix of statistics and computer science both. So where you have the primitive versions of language models. Okay, so language models aims specifically the aim of or the main function of these models is to predict the next word. So this is something I think you might have commonly seen while using Gmail or your any email platform. So basically Microsoft Outlook or whatever. So you will see a next word getting predicted. So this is being available in Gmail for quite some years. So this is one of the earliest form of language models, which is available for public use as well. And next phase is to use neural networks as the architecture of the neural networks evolved over a period of time. So people started experimenting or researching on how neural networks can be used for this purpose. So that is in where you can see RNNs, CNNs are being used to even process, understand, let's say, components or patterns within the text, and then see how it can be utilized for further downstream processes. Okay, and then the last, I would say, the current era which we are in, which is almost a paradigm shift in your language modeling phase. So where you can process billions and billions of texts parallelly because of you can say advancements in let's say the available chips, so especially GPUs and CPUs and TPUs available in the market, and also evolution in the neural network architectures. Okay, so how this helped or this combined together helped process information faster and parallelly so that these models can take in or learn from, let's say, literally billions and billions of tokens or corpus of data, and then also generalize what it has learned so that it overcomes the challenges from the previous phases or previous era of language models as well. Okay? So this is in a nutshell the various four phases of evolution for I would say language modeling. We'll go in details a little bit around, or we'll touch base on each of these components as well. So we'll start with NLP. So the three main, I would say, terminologies which anyone should be aware. So whether it is data scientist or maybe someone in a business role, so everyone have to have this kind of basic definition knowledge as well, because this is critical in future for every task we do. Okay, so we'll see some of the components. So one is tokenization. So tokenization is nothing but simply processing or converting a sentence into its word form. So let's say let's take the word natural language processing. When you tokenize, it becomes natural as one token, which is one word, and then language, and then processor. So these are the three different tokens, and these models or machines learn information in terms of tokens or individual words. Okay. So stemming and lemmatization here. So stemming is nothing but reducing the words to its base form. So for example, you can see in the screen, the running can be shortened and reduced to its base form, which is run, because both gives the same meaning. Whether it is running, only the tense, or I would say how it is being used in the sentence vary. But overall, the meaning of the word running or run gives the same, I would say, basic information to any user. So stemming is one of the technique to reduce the amount of input, as well as also understand the base word from a grammatical perspective. Lemmatization again is similar to, you can say, stemming, but however, here it reduces the words to its dictionary form. Okay. Here, let's say if there is a word better, it becomes good, because better means it is a comparative word or a relative term where you are comparing one with the another, and basically you're trying to say this is much good than the previous one. So that is how lemmatization helps as well. Then later, the last part is called parts of speech or POS tagging. This is especially a critical and important when you want to understand the different parts of a speech. Then down in your basically during your school days, you might have learned grammar. So where in English grammar you would be uh, asked to actually tag the parts of a sentence and things like that. Where what is a noun, what is an adjective, or point out the verb. So something similar happens here as well in while teaching a machine, as we did for our curriculum as well, or in our academic side as well. So same. So here we'll try to break down a sentence into its parts or the nature, and then it gets tagged as well. So this is what basically was done in NLP phase, where you try to understand the crux of the language and how the industry or how the human languages are being interpreted and used. Okay. Next, we'll see something about language model. So in language models, Ngram is one of, I would say, the earliest approaches which help in building the primitive or the early stage language models. So here, Ngram analysis is nothing but it helps you break down or understand the word from different combinations. So 1 gram here, nothing but one single word, and then 2 and 3 and up, and you can keep on increasing this combination, and how these words when combined together gives a different meaning. So that's what will be, or that's what basically the research was done to understand how a combination of words can be used and built and rolled up to get a complete understanding of a sentence, or maybe how the sentences or language is built or spoken. Okay, so this is how you can see, as you can see in the screen, so how each and every word individually as well as in combination gives some amount of meaning as well. Okay? And each word has its own meaning, or each combination has its own meaning. So this is how the patterns and let's say the basic work was done in the initial stages to break down the patterns and make the machines learn about the same as well. Okay. Now we'll see a little bit around neural language models. So as CNNs and RNNs were introduced, or these architectures were introduced, so the same methodologies or same, I would say, architectures were also experimented for text-based analysis as well. So here you'll see how these neural networks were used to understand, land the pattern from the text, and then move on to even predicting the next word, or maybe complete the next text as well. Okay. So here it is simply, you can say, a combination of kind of an independent AI system as well as some kind of rules as well. So rules in the sense, the rules of a language itself. So English grammar has its certain language. So how those languages or rules can be incorporated within these models, and how that can be used as well to generate a text out of it. Okay. So how these neural networks here especially works is, so for example, let's take CNN. So CNNs use, or you might have heard this terminology called convolutions. So convolutions especially helps in understanding the pattern or local pattern within, let's say, parts of a speech or a sentence. Okay. And then it helps you identify the hidden patterns between different combinations of words, which you might have seen in Ngram earlier. So that is something which gets partially covered when we started using neural language models. And then comes recurrence. So recurrence is nothing but try to understand the sequence of words. Mostly recurrence is associated with time series based data, you can say. But here in this context, we'll try to understand how the previous word is associated with the next word, and then how the sequence of words gives a complete meaning in altogether. So that is how recurrence was being used in neural language model building exercises or researches. Okay. So this is overall about some of the earlier stages of neural language models, and some models which are available is LSTMs, GRUs, and some multi-directional RNNs as well, which I could say as the early stage models which was built. Okay. Next, we'll see the turning point of uh, all this. I can say before that we can see the drawbacks of neural language models. The main drawback was we'll not be able to process information or train these models parallelly. So basically you will have to sequentially give the input, which takes a hell lot of time and computational power. Okay. And also you need huge volumes of data, which has been broken down into its grammatical form as well. So that was also one of the drawbacks of this neural language models. Okay. So this particular concept or this particular drawback was overcome in the next phase by the release of this very famous research paper called Attention is All You Need by the researchers of Google. So Google introduced this concept and also the transformer architecture, which is again a shift from how the language or NLP in this area was evolving or evolved altogether. Okay. So you can read completely the depth of this paper in this particular source. You can simply search "Attention is all you need" and definitely you will get this long research paper. You can see the nitty-gritty technical details of this paper, how the architecture works for transformers. But let's see just some of the highlights here. So transformer architecture back in 2017 when it was introduced, if you put it in a nutshell or a simple terms, let's say we are teaching a child to learn a particular language. What it does basically is, let's say it allows the child to see and understand the whole sentences at once and making the learning faster. Instead of seeing word by word or maybe letter by letter, the transformer architecture basically lets you see or read the entire sentence and then understand the pattern by yourself and make meaning out of it. So that's basically the shift, and that is how it transformer architectures basically help in processing information faster and also helps you retain certain longer dependencies and as well as uh, let's say patterns which was not able to or which we were not able to identify in the earlier stages of CNNs and RNNs. Okay. And another key concept is attention mechanism. So here attention is nothing but helps you focus on some of the most important words so that it helps you understand and learn the language or maybe the content faster. So that is how attention helps. And there is another subtopic of attention called self-attention. So self-attention is nothing but understanding the connections between different words, but across the entire corpus of data. Let's say you have a one-page document. There is a sentence in the first of the, let's say the first sentence in the page, and there is, let's say somewhere down the line, the last paragraph, there is another sentence, and it is linked with the first sentence in the same page. So self-attention is one of the technique or basically how this transformer architecture was built in, which helps you relate the last sentence is the first sentence so that it carries a history of previous information. And this specifically, this particular topic of self-attention helps you retain and also generalize the learning of this machine learning models as well. Okay. And some of the other techniques or some of the other advantages of transformer architecture is simply you can process data parallelly, which helps in reducing the amount of time used to train these models. And then also it is comparatively better than the previous neural network models, or I would say the primitive RNNs and CNN based models. Okay. So it basically transformers in nutshell has a simple architecture called encoder and decoder. You can read in detail about encoder decoder in this particular paper as well as Google. It's a nice topic and it will be interesting for you to learn as well as the basics of how these models were built and then how it evolved over a period of time as well. Okay, so basically encoder is nothing but it takes the entire input sequence at once, focuses on understanding the input sequence using self-attention, and decoder takes the encoder's output and the previously generated output tokens, then focuses on generating the output sequence using both self-attention and encoder-decoder attention. So it is like a second layer. It tries to reproduce from what the encoder has learned, and it also tries to decode from its own, let's say, architecture as well. So that is how these encoder-decoders were designed. Okay. So we'll move on to next. Maybe we'll spend a little time of understanding how this actually works as well. So let's take this particular sentence here. Once upon a time in a faraway land, there was a brave knight. Let's assume this is a small story, and the knight had a loyal horse, and one day they set out on an adventure to rescue a princess. Okay. So here, let's see what is attention and what is self-attention. Okay. So the knight had a loyal horse. So this particular sentence, the knight here, which is appearing in the second as a second sentence in this particular story or paragraph, you can see. So when you say knight, attention is nothing but which helps you understand. When you say knight means in the previous sentence, you can see there was a mention about a brave knight. So now the models will try to relate knight means the brave knight which was mentioned in the previous sentence for you. Okay. So the knight here is related to this brave knight. So this is what attention mechanisms help you do. And self-attention, which is being used in transformers, how this works is, let's say, let's take the sentence, they set out on an adventure to rescue the princess. Now they, who are they? So if only this sentence is being given, or maybe only this sentence is available, it will be very difficult to understand who are they. Now when you have the whole corpus given, these models as humans would also try to analyze or process the information. It tries to understand they means it is actually the brave knight and the loyal horse both are actually setting out in an adventure to rescue the princess. What it does is actually it takes the long-term understanding, which is like one sentence prior, it was mentioned about a brave knight, and the second sentence it was mentioned about a loyal horse and what they're going to do in future, which is nothing but rescue a princess. So self-attention helps to keep or retain the historical information and also set out to see what is available as a next, which is basically during the learning phase and helps you retain this information. Okay, so in a nutshell, it is simply instead of teaching one word at a time, the entire sentence or let's say the corpus of information is given and allowed the machine basically how you would normally do or how normally we as a human would have learned over a period of time. The same happens here as well. Okay, and then understand the patterns. So this is all about attention, how this this is one of, I would say, the key elements of, I would say, transformers or how LLMs were built. Okay. Now we'll simply see and how the LLM workflow will look like. I think you might be much familiar by this time using some of the LLMs, especially maybe ChatGPT or maybe Google's Bard. So basically, for your academic purposes as well. So these LLMs are really good, generating almost human-like texts, which is hardly differentiable as well. So there was a test very recently done by the researchers across different universities to see how well human-generated and these machine-generated outputs look like. This was manually evaluated by a group of people, and the results were almost, I would say, insignificant in the sense. The results were almost close to 50%. So where it means it's hardly we'll be able to differentiate between a human and an AI generated content. So that is how the current model's evolution looks like. Okay. So from an workflow perspective, it is simple. You give an input, which is a simple natural language input, and the natural language can be any language of your preference. The models can understand. Okay, it can be English or it can be any vernacular language the model was trained upon. And then these models process the information and then gives you an output in terms of an response, which is again a text. Okay, so this is text in and text output. So basically LLMs in its basic form takes text as an input and gives text as an output as well. Okay, so this is the basic workflow of an LLM. So we'll just see some random handpicked LLM timelines from back when in 2017 when this paper of Google researchers were released, attention is all you need. So since then, there has been a lot of models coming into the market. Though the hype started back in 2022 towards the end of the year, but however, these models are being developed for quite some time, basically because of the introduction of transformers architecture. So right from starting from the GPT-1 or BERT models, which was also introduced during Attention is All You Need paper release. And then in 2022 is where you can see these models were commercially made available on a larger scale for general public. Okay, so that was basically how the attention or maybe the attention of the general public was quite higher compared with the earlier stages or maybe earlier years, I would say. Okay, so basically ChatGPT is one of the large language model which actually took the market by storm and literally changed everything with respect to content generation. So basically, I would say I would attribute ChatGPT release as an engineering marvel rather than a language model, because from a language model perspective, these concepts is in place for quite some time and it is available as well for in the market for quite some years and researches has been going on. But how these models can be used by a common man or a lay person in general, so that is what the turning point was when ChatGPT was released to the general public. So how people can use, get to interact with these LLMs, get some answers, and also which can be done in seconds, basically, or maybe microseconds in getting the answers as well. So instead of, let's say, searching through multiple textbooks, how you can directly get your answer or maybe summary. So that's what changed the entire market, and that's how the hype was created for LLMs as well. And you can see recently the various different models as well, which was released up to, let's say, the recent months or this quarter of the year as well. So some of the top model which is available. And now you can see the concept of small language models is also getting popular by the release of Microsoft's 5.3. So 5.3 is nothing but it's a family of models which is smaller in size, which can be deployed in, let's say, IoT or edge devices as well, let's say in your mobile phones or any devices, and it seamlessly runs and gives the same superior performance as a large language model. Okay, so almost equivalent to a large language model output. So some of the research is currently going on building these small language models, which will be specifically trained for particular task and then deployed in a particular environment so that users can use it without releasing their data or maybe the data going out in general public. Okay. Well, we'll see some of the language models and the landscapes. So basically, what are those technical details behind these language models as well? So it starts from trees and ends with transformers, which is the recent evolution of, I would say, language model architecture from an architecture perspective. Okay, we'll start with recursive neural networks, RNNs. So here the LLMs process data kind of like an tree-like structure. You can, I think you might be familiar with the tree-based machine learning models. So here the data is processed in a structured tree-like basis, where you combine smaller chunks of information or smaller pieces of sentences and then form a larger, let's say, sentence or larger ones. Okay? So this particular concept or these particular models, especially where helpful in understanding sentiment. So basically, the application from an application perspective, if you want to understand what was the overall sentiment of a particular sentence or maybe a group of sentences, these particular models can help you well. Okay, so one of the available model you can see is Stanford's sentiment tree bank model. So this was developed for the purpose of analyzing the sentiment. The next is another type of, I would say, language models, which is called sequence to sequence model. So as the name sequence to sequence literally mean, these LLMs also takes inputs in a sequence and produce a new sequence as an output. So these kind of models or architectures are specifically helpful in terms of, from an application perspective, in translation use cases. So where you want to translate a sentence from one language to another, these models were really helpful, or these architectures or this type of language models were useful. Okay, and they do a reasonably decent job in text summarization as well as uh, to a certain amount generation as well. Okay. The next comes hierarchical models. Hierarchical models is simply like assume you are reading a book. First, you understand the individual meaning of the words. Then you try to correlate these words into a sentence, and then the sentence into a paragraph, and then finally you will understand the entire chapter and then the book. So hierarchy is similar. So you will understand, or the LLMs process the information in layers. So first it understands the smaller components, and then the bigger picture. So these kind of models especially was helpful in document classification and also understanding. There is this topic called topic modeling. Topic modeling is nothing but you given set of input as a text and try to understand what was the major key topic which was discussed in that particular text. Okay, so these models were especially helpful in understanding topic modeling. Okay, so from an industry perspective, topic modeling is very crucial when you want to summarize an information and also need to understand what is the key topic which was discussed from a larger corpus of data. The corpus of data can be a document, let's say a company's legal document, and you want to understand what was the crux of information which was discussed. Or let's say you have a call conversation, okay, or a transcription available from an voice call. Let's say the call center is making call to different customers, which is widely being followed by many industries, almost every industry, and you want to understand the key or crux of the information discussed. So that's where topic modeling helps you, where you can understand in one or two words or sentences what is the key topic which was discussed. Okay, and last comes I would say transformers. So here the transformers literally are, I would say, more generalized models. Okay, and when I say more generalized models, it can literally perform all the tasks which I was discussing earlier by RNN sequence and hierarchical, and also in the same time generate texts as well. So basically it is more generalized model, and it is more creative in nature as well, where it can learn certain input and also give or produce an output which it might not have been exposed to us in during the learning phase as well. Okay, so this I would say as uh, maybe an advantage as well as a disadvantage of these models, because when it tries to create an output which it has never learned during the learning phase, there is this term called hallucinations in LLMs, where they try to hallucinate certain information when you don't know the answer. Okay, so let's say you are in an interview, you were asked a question, maybe you didn't know the answer, and maybe we tried to cook up some answers. That is a human nature. So that is exactly what these LLMs also do, where they try to hallucinate certain information, which in a way is, I would say, it has its pros and cons. When you want it to be more creative, like writing a story, this kind of techniques or this kind of feature will help. Whereas when you want some specific answers, let's say you are processing an document which is an annual report of a company, and you want to know what is the last year's overall revenue for the company. So here, if the LLM hallucinates and gives a wrong answer, then it becomes a serious issue. So you want exactly the same information which was available in the annual report. Okay. So these are some of, I would say, the challenges while using LLMs in real life or real use cases in the industry. Okay. And I will see how do these large language models work. We'll just quickly see the four key components here. So word embeddings in simple terms is nothing but converting the words into a number. So basically we'll convert a text into a binary format, which we represent in terms of vector in a vector space. Okay. And then comes this topic called positional encoding. So positional encoding is nothing but understand this position of each words, and when we interchange the position, how the meaning of those sentences change as well. So this is how the language models or LLMs also understand how the position of a word is critical. And transformers, as we discussed some time back in detail as well. So how self-attention and the various let's say learning or propagation techniques helps it understand and process information and also understand the complex patterns. And finally, text generation, which is the primary purpose of LLMs as well, so to produce and text output for the given input. Okay. We'll just see some of the key some of these terminologies in details as well. So word embeddings, what does word embedding mean as well? So let's say when you, I try to put as much as simple as possible so that anyone can understand here. Okay. So let's assume word embedding can be compared to something giving each word or associating each word with a palette of colors. Okay. So for example, closely related words will have similar palette of colors, and distantly related words will have basically a distinct colors from the other ones as well. Okay. So for example, let's take sun, moon, and fish here. If you see sun and moon are closely related, if I were to assign certain colors to these two words, I can represent it in this particular form of yellow. This is one of the palettes available for yellow, and then maybe moon, and they both are closely related. Let's take fish, which is completely distinct and distant from these two words, and it gets a completely different color. Okay. So this is how machines also try to learn, not exactly as a color palette, but just I put this as an example just to make it easy to understand. Okay. So similarly, we'll see how positional encoding works as well. Let's say you are, imagine that you are arranging a set of toys, like maybe Lego or something, a blocks of toys. And each block, when it is arranged in a certain sequence, it gives a certain output for you. When you demolish and then rearrange those words in a different, rearrange those blocks in a different, I would say, structure, it gives basically a different meaning altogether. Okay, so let's take this sentence here. So positional glitter powers meaning, and then meaning powers positional glitter. So both has similar meaning, and the sequence of words is also being interchanged. So basically, you can assume that, or maybe imagine positional encoding to an kind of an imaginary or a magical glitter. And this glitter, you can say, is the amount of intensity it gives, or basically the color palette shines. And this is unique, like a fingerprint for each of the words as well. So this is how the machines also try to understand how the position of the words when it is being interchanged, how the meaning also changes. Okay, so basically this glitter, which is helping to understand the position of the word, is what is called it as positional encoding in LLMs. Okay. Lastly, we'll see the transformer, basically the encoder decoder architecture. So in simple terms, encoder reads and understands the input information. A decoder basically takes the understanding from the encoder, generates the output, but one step at a time. Okay. So encoder takes the raw data, which is fed into the model, converts the data into binary format, which is embeddings, then adds positional information. Then encoder focuses on important parts, which is again the self-attention technique here, and then processes or creates an output which will be ready for consumption of the decoder. Okay. So what decoder does is takes the input basically from encoder, which is during the training phase, okay, converts the target into again text to basically it adds its own positional embedding information, and then produces an output or gives a certain output which can be finally displayed to the end user in the last form, which is the output layer. Yeah, and this is going to be an iterative process during the training phase where the input and output almost matches, and that is how these models try to learn and also understand the complex patterns within human languages. Okay. So this is from an transformer encoder decoder perspective. Okay. Though the individual operations within encoder and decoder are done or maybe executed parallelly, the encoder and decoder architecture basically runs sequentially. So basically input converting self-attention, all this can be done parallelly while training the let's say large language model. However, the decoder needs input from encoder. So this process will be sequential. And there is some researches currently going on as well on different encoder decoder mechanisms as well. There are different architectures are also available as of today, which will make this process even faster. Okay. Lastly, we'll see how text is being generated. This is very simple. Just to give you an idea again, how an input is given and the LLM processes the input and then gives you a certain output. Again, this is simple auto regression techniques. It generates in certain words based on the previous words and then gives you an output. Okay. We'll see the different applications. Now we'll get into the applications of LLM on a broad spectrum. You can say these are the four areas where LLMs can be utilized. Basically, content or text generation, text summarization, code generation, especially helpful for IT industry where we want to write complex codes in any language, programming language, given input as any human language, which is natural language. Then lastly, some kind of search or semantic search of, let's say, text as well within large corpus of information. Okay, so these are some of the broad areas, and you can read here some of the individual use cases associated with these broad areas as well. But now for this session, what we'll do is we'll see some of the use cases which is specifically executed or which can be implemented in an end-to-end fashion using some of the cloud architecture or cloud platforms available in the market. So this particular conversation summary here, let's say this particular use case can be implemented using Microsoft Azure platform, using Azure OpenAI services, which is being offered by Microsoft, and in combination with OpenAI models, which is the GPT models, basically 4.4.0 and everything is available here. So where you take a conversation, so conversation here can be any conversation, maybe the conversation happening in this call or in this session, or maybe a conversation in call centers between your call center agents and your customers, and how that information can be processed and then get an abstractive or an extractive summary. Okay. So extractive summary is nothing but it selects certain keywords from the original text and produces as a summary. Abstractive summarization is nothing but it takes the input or basically the input information which we are giving, rewrites the entire information into a complete using a different language or parts of a speech, and then gives a condensed information. Okay, so that's the difference between basically extractive and abstractive. Extractive will be much faster because you just take few key sentences and then give a summary, whereas abstractive is understand everything and recreate every sentence into a new format, which will be much easier to understand by the human. So basically, it will be more human-like. Okay. So some of the challenges you might face in this process is the pre-processing step, as you can see here. PII information is personally identifiable information. This is one of the key topics where most of us or most industries struggle as well. You cannot leak any personally identifiable information of your customer to the external environment or any infrastructure you use. So hence filtering or removing any personally identifiable information is critical. Okay. This is also critical in terms of government legislations as well or laws, especially you might have heard this popular law by EU, GDPR, and also EU AI law, which was recently passed in the EU Parliament as well in May. So where you cannot leak in any way the personally identifiable information of a individual person into these kind of AI systems. Okay, and also removing some kind of noise as well. When I say noise, maybe let's say it's a call center call, you might begin the call to maybe engage your customer with some certain, let's say, icebreakers, and then start. And icebreakers are not going to be much helpful in terms of understanding the overall key topic or the summary of the conversation. So those things has to be eliminated as well. Okay, so steps of pre-processing has to be taken so that PA, some kind of noises in the data has been removed, and only the necessary information goes into the next phase, which is using the uh, actual LLMs. Okay, this also helps in another way because these LLMs are costly. So you use or you pay as you use these API services or APIs of these models from OpenAI. So the more the input you give, the more the money you pay as well to use these services. So that's where it becomes critical in also reducing or giving the right information and getting the right output. Okay. So this is one use case on Azure, and again another use case again using Microsoft Azure, but it's more about a classic use case of LLM, which is a chatbot. The difference here is using the traditional chatbot, which is a rule-based engine, in combination with your LLMs, which is more creative in nature. Okay, you cannot expose your data completely to these LLMs as well. So hence you need to go in tandem with your rule-based engine as well as your generative AI capabilities, which is LLMs too. So how that can be utilized is you can see in this use case here, where you use your rule-based engine. So the user gives a certain question. If the rule-based engine is not able to understand the question, it goes and gets some input from Azure, Azure's OpenAI. Here it is the LLM here, and then some of the PA information gets removed because this LLMs has the capability to understand what is PAI and what is not PAI. It also takes some basic information from your knowledge base. KB here is knowledge base, nothing but your company's personal data or organizational data, and then that output goes into the final interface of your rule-based engine. Okay, so the rule-based engine, whenever it fails to answer a certain question or a combination of word is used which the rule-based engine is not able to understand, it goes and taps your LLMs. So that LLMs optimally used, and also your rule-based engine answers certain PAI-related information can be answered using your rule-based engines. Next use case, we'll see something around using Google Cloud Platform, okay, or the Gemini model. So this is more about document AI or processing documents and then using that information. I have not discussed this particular topic called retrieval augmented generation, RAG, as popularly called. So RAG is nothing but these LLMs are trained in certain amount of information which is publicly available. But there are certain amount of data, basically a huge amount of data, which each company has, which is proprietary to their own organization or maybe own institute, which cannot be released to general public. So instead of training the entire large language model with this kind of proprietary information, which is going to be costly, when I say costly, it's tremendous amount of efforts has to be put and extremely costly, and it is also environmentally not friendly because it's going to emit in terms of carbon emission, it's going to pollute the environment even more higher. So instead, a mechanism called rack will be used where you break down your proprietary information. Let's assume here it is some kind of PDF or Word documents. Uh, Maybe chunk those information into smaller components, embed it, basically convert them into vectors. And there are specific databases called vector databases, which can store this vector information, which is the numerical, let's say, form of the text. And you can apply a vector search engine or a vector search model over these databases, search those information and give us a context to your LLMs. So basically what it does is user asks a specific information about a company's proprietary data, which the LLMs will not be aware of. Whereas the LLMs or this particular architecture will trigger another pipeline which goes to your company knowledge base, which is nothing but your vector database, uses that input, searches that particular database and see similar kind of information. Basically, it works on similarity search. So it finds similar kind of outputs or information from the database and then gives that as a context again to the LLM. So the user question and then the context which has been searched from this knowledge base, both together goes as an input prompt to your LLM. The LLM does its magic and then generates a final output answering the users. Okay, so this is a infrastructure as a service which was recently announced by Google during their Google I/O as well. So here Vertex AI is Vertex AI is the Google's AI platform as a service. Okay, so OOTB here nothing but it is out of the box services offered by Google. Okay, and again this is also in Google based. I'll just quickly not go into details, but just to showcase LLMs can also take multiple inputs or multimodal inputs can be given as well. For these LLMs, at least the ones which are available in the recent few months, can take input in any form, understand it, and then produce a certain summary. So here you can take inputs from, let's say, YouTube or any proprietary audio, video information, pass to your LLM, summarize the information, and then answer a question. From an industry perspective, I'll say where it will be helpful. There is this topic, especially in the financial industry, called earnings call. So earnings call is where you discuss about a company's growth, how the performance is, and how the companies are overall performing. This is very common for every industry. And if you are in a financial institute, especially, you need to also understand, as in from a lender perspective, how these companies are performing before lending money as well. So you can understand from this earnings call how this company's performance is, create a summary so that your analysts can read through this information, or basically the short summary instead of going through the entire video or audio recordings, and then save time. So basically here, in the benefit of all the LLMs literally is a productivity enhancement. So literally it is going to help you improve productivity in terms of saving how many hours has been spent in doing a certain job in the past. Okay, so let's say it takes let's say 2 to 3 days to generate certain text, maybe write a short essay or maybe one of the chapters in a book. Nowadays using LLMs you can do it within hours. So basically it reduces the amount of time spent. So that is basically the benefit perspective from an LLM. Okay, so we'll see some of the applications here. It's listed down. I'm not going into details. I'll share the link as well of this content. You can go in details for various let's say industry areas. What are the simple applications of LLMs and how it can be utilized in the different sections as well. Okay. Now we'll quickly see, spend maybe some minutes around how it can be used in your local machine. Okay. In the meantime, I'll try and open my application as well for you. Okay, so one of the application is called Olama. So Olama helps you run these large language models in your local machine. Okay, you can visit this website Olama, download depending upon your OS preference, download the correct exe file, install this application. So basically what this application does is it creates a server and a client. So server in the sense it creates a local API kind of a server within your laptop or computer, which hosts the large language models. And whenever you ask a certain question from the front end, it goes and retrieves or hits this API, which is the local server, which is running within your laptop, gets the answer and then displays it. So this runs typically without internet access. So once using internet access, you download this application, you download the large language model, let's say Llama 3, and then run it without internet access. And you can basically interact with these LLMs. Okay. Basically, Olama works. The only disadvantage in Olama is it has it works in a command line interface or CLI mode. So basically the user interface is CLI. So you can actually install. Once installed, you can check whether the installation is correct in your terminal, and then you can pull whatever models you want. It gets downloaded to your local, and once downloaded, you can start using these models as well. Okay, so literally you can see a lot of models are available in Olama website. You can, by default, Olama has been integrated with some of the top open source large language models available. So basically, you can just download any of these models listed in Olama website into your local, and then start running them in your local machine. Okay. So another application which is comparatively better than previous Olama is Jan. Jan is again in a beta testing mode right now. So here also, you depending upon your operating system, you can actually download the correct software. And again, it creates the same environment as it does with Olama, creates a server for you to host these LLMs and then use a user interface. The advantage here is the user interface is much more friendly, and how it looks like while using ChatGPT as of today. So it gives you a chatbot kind of an experience. You ask a question and answer, and it answers you. And it also helps you. Let's say you have certain proprietary information, you can upload that document. Let's say it is available in terms of a PDF document or an Excel sheet. You can upload that document and also interact with that document locally without your data going into general or public internet. Okay, so this is available in a website called jan.ai. It is in a beta phase right now. So what we can do now is I'll just quickly try to load these models quickly for you so that I can show you a demo of how Jan looks like. Let me share my screen. Okay, so this is how the Jan interface looks like. Basically, I chose this particular application because you necessarily need not have any coding experience. It's a no code, low code kind of an environment where anyone can use. Just load the model which you want and then start using it. So let me show you also the hub here. So depending on your local machine capability, the RAM and the GPU availability of your particular laptop or machine, there is, by default, it gauges whether it can be run or not. By default, Jan has a lot of open source models which are preloaded. You can also use API based models like ChatGPT or OpenAI models as well, provided you have an API key, which is something which you will get only when you procure the service. Okay, let's say you have gone into a pricing model, you have procured the OpenAI service, you have the API key tokens, you can input the API key tokens and still work. Okay. However, uh, data will go out in that case because this is again an API based service which needs internet access. It's better to use completely free downloadable models like Llama 2 or Llama series and Llama 3. Okay, and literally you can see a lot of models are available here. You can download. So it downloads the models to your local environment and gives you a user interface as well here, where you can actually ask and interact with the environment. So here I have used Llama 3 8 billion parameter model into my local, so which I have pre-downloaded and loaded into my system here, and then it generates the responses based on the model which you have selected here. Okay, and this has a RAG platform as well. This is one advantage in Jan, where you can upload a document using the attach symbol here, and then you can also define how the documents can be chunked, and you can give how the prompt input also has to be for this RAG platform altogether. And basically you can interact with the document you have uploaded to. Okay, all this in your local system without your data going to public internet and even without internet access. Okay, so my laptop doesn't have that much amount of RAM or GPU speed. You can see it's slow. At least I would say a minimum 16 GB of CPU is necessary to run these models locally, okay, so that the latency will be less. Okay. So in the meantime, I think we have one of the question as well here. I can see in the chat window from Mark. Mark, thank you for asking the question. So one is to enhance personalized user experience. See, hyper personalization is one of the key benefits of LLMs, because LLMs can help you understand your customer from an industry perspective in a deep and closely related manner. Okay. But the only concern here, as you rightly pointed out, is bias and privacy. Okay. Each and every model has its own bias and privacy. Means data privacy changes from each industry. In a highly regulated industry, for example, pharma or healthcare industry and banking industry, these are highly regulated industries. Reason being, they are answerable to their local legislations or governments whenever there is an information leakage. Okay. There are also few industries whereas these kind of strict regulations are not available. So depending upon the industry, data privacy can vary. Okay. But bias, so there are few guardrails which can be placed. So I'll go back to the presentation. Maybe I can show you one of the architecture was how PIA information can be I would say removed. If you see in the Microsoft Azure use case perspective, so this is one way of putting guardrails in your LLMs and also mm, putting some guardrails on your output as well, of not giving any offensive answers as well and biased answers as well. Okay, so at least in the recent months, these kind of LLM providers give some output of what data sets were basically used, so that the end users will understand the amount of bias these models by default holds. Okay, when these models were initially released, there was a very high gender bias. Okay, I was doing my own research as well. When you use a specific terminology, for example, let's say a doctor or a consultant, it always refers to that particular personality as he. It never addresses as a she, because anyone can be a doctor, whether irrespective of a gender. So that was one of the bias which was default incorporated into these models. But as these models evolved, these biases has been by default addressed in the foundational models itself. And apart from that, you can place your rule-based engines, which is nothing but guardrails, which will also help prevent these biases. Okay, so that is something which we can do it as a simple rule-based engine. We don't need any sophisticated machine learning here. If I were to make, I think next question is from Alvin here. If I were to make my own LLM models, what would be the best model for me to start with? Okay, so honestly, I would say don't ever try to make your own LLM. It's a very costly affair. Costly affair in the sense, from an environmental perspective or a responsible AI perspective, I would recommend not to go for it. Reason being, it consumes a lot of computational resource, be it local or be it cloud-based service. Of course, you need cloud-based kind of a service which emits lots of carbon dioxide to the environment. I was from I had some quite 10 years of experience in manufacturing sector. So that's the reason I'll be very cautious about carbon emission, because that is one of the key components we try to address in the manufacturing sector. Okay. But however, if you want to start with BERT, which is a very primitive model of transformer architecture, you can start from BERT. The reason being, BERT helps you understand how these large language models works from an let's say foundational perspective, and then you can see how it has evolved over a period of time. Okay, and RAG or retrieval augmented generation is something I would personally recommend. Reason being, you have well enough generalized large language models or foundation models already available in terms of Llama 3, GPT, or Gemini. Lots are available, Mistral, Falcon, and you can always use that and then go ahead with inputting your own information and making the model customized for your personal use. Okay. So you can explore more about RAG, which is less compute intensive, and also it's not going to pollute the environment much as well. Okay.
If anyone else have a question, please turn on your camera and you can ask. Also, I can post it in the chat. And I think there was one more question, Mr. Arockia, there was by why run. So if you see 4 o'clock,
Okay.
if Solat, yeah, previous, yeah.
Okay. Okay. Got it. Perfect. Let me scroll. Yes. Mm, is that Meta AI part of Meta company which currently handle on Facebook, WhatsApp, etc.? Okay. Yeah, Meta AI platform which you see or which you saw in my screen earlier is something which is a front end of an application offered by Facebook or Meta. Currently, it is not available in all the countries. They have released in specific countries as of today, which will be also soon rolled out globally. So it is similar. I think you might be familiar now with ChatGPT interface. I think most of you might be already using as well. So Meta AI is something similar. Again, it's a multimodal kind of an environment where you can generate text, also generate images, and it can take inputs in any form and create output as well. Okay, so that's how Meta AI platform currently works. Okay. Cost-wise, is it better to use commercial LLM, deploy open source models on cloud, or deploy on-prem? Okay, so for a regulated industry, I'll take it in two terms. I would personally prefer an on-prem deployment. The reason being my data will reside only in my own data center and never goes out. Okay, but the only drawback or one of the challenge will be setting up your on-premises infrastructure. Most data centers for the companies will have CPU capacity. Okay, but GPU capacity is not something which not every company thinks about. Okay, so when you want to use on-premises kind of in an on-premises mode LLMs, CPU is necessary. Sorry, GPUs are necessary. Okay, and nowadays many companies provide that as a service as well. One of the companies called Red Hat. Red Hat offers a service called OpenShift and OpenShift AI, which is specifically GPU services, which is capable of running LLMs in your own on-premises systems. Let's say here a company's data center or data servers, and basically they provide the physical infrastructure as well as the software component inbuilt as a package. Okay, so when you order a certain component, they give you a physical uh, GPU which has pre-installed some kind, I say, softwares. Basically, I'd say Jupyter Notebook, for example, which is pre-configured so that data scientists or analysts can directly start working on and doing their job. Okay, so that is from an usage perspective. So if the information is confidential and data privacy is of paramount in importance, then on-prem and private LLM is better, and open source LLMs are better. The reason being you can download the entire model weights architecture into your local system. Okay, but if you're using for general purpose, let's say your marketing team wants, or let's say I'm a part of marketing team, I want to generate certain images or text content for the ad I'm going to create, which is not too much of an sensitive information, because any of this information is going to go public for the customers. So here I can go for commercial LLMs, which are much robust and much the output wise, the outputs are much refined as well and crystal clear too. And it involves very less work in the terms of setting up that infrastructure, and platform is easy to do. You can just use let's say subscribe for the service and then start using it even without coding knowledge.
That's good. Okay, there's few more questions. If you see,
Yeah,
if
yeah.
you can take up one or two from there, it would be
Yeah,
great.
yeah, yeah, yeah. So for project payment, high security on-prem is better for flexibility and cost. Load is good. Yeah, someone has already, Mark, I think, has also tried to answer some of the questions. Thank you, Mark.
Yeah,
Yeah, I totally agree. When it is, as I said, if data privacy is of importance, then never go for API-based LLM services, which is not recommended here. Okay. Previous generation algorithms by allowing parallelization, attention and stuff being working apart. Okay, so the current challenges is as I think one of the questions was also pointing out, that was addressing the bias. Okay, so bias here is one of the challenge which is currently being addressed by these while building LLMs. as I said, when initially these models were released, there was a certain amount of bias. I would say completely it has not been eliminated, but still I'd say it's a work in progress, and there are ways how guardrails can be put on these LLMs. Basically, you can say a kind of a boundary so that it filters the information both ways. So while sending out and also while getting. Okay, so that is one of the current researches going on with respect to LLMs. Okay, and from parallelization's perspective, especially in RAG, as previously we were trying to process information in chunks, in paragraphs. Now, how this information can be processed or maybe stored from a sentence perspective and retrieve information from combining these sentences. Okay, so basically you're making the chunks even smaller so that your response will be more accurate as well. Okay, so that's, I would say, some of the researches going on around how well the RAG architecture can be optimized too. Okay, from an end-to-end solutioning perspective.
Thank you on that, Mr. Arockia. You can see from the last, there is three. If you want to take any one of it, will be great. If you're okay
Yeah,
with
yeah,
it.
yeah. Okay. Okay, so how do we confirm the model is not hallucinating when evaluating the model? There are many evaluation techniques for understanding or evaluating a large language model. You can simply Google as well. I'm not going into details of those techniques, but basically hallucination is something which can be prevented from prompt engineering. Prompt engineering is an evolving topic which got evolved or which got created as LLMs were introduced into the market. So basically, you will prevent hallucinations by keeping proper input or prompt templates. So prompt templates is nothing but, if you put it in simple terms, you will instruct the LLMs basically not to give any offensive answers or to give answers which is not available in its context. Okay, so you give specific clear instructions and then pass your questions so that the model actually performs within that boundary and gives the output within the boundary. So this is a very common way of preventing hallucinations in LLMs. Okay, so it's simple prompt engineering task, not necessarily an I would say an machine learning task heavily involved here.
Thank you on that, Arockia. So
Yep. Yep.
yes, so if you have some time, you can take one more. If not, we stop here. How do you
Yep.
think?
Yep. 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 But and then maybe the next questions I think is around one of is around hallucinations and risks. Okay, risk LLMs has its own risks. Okay, so there is a huge list of risks associated with LLMs. You can refer to red teaming efforts of OpenAI. So OpenAI has its own red team. You can see the various risks of using an LLM. They have already listed down. You can go in minute details. Okay, one of the risk is prompt injection as well, where you give some kind of prompts which will provoke the LLMs to give certain, sometimes offensive, sometimes certain answers which you are not supposed to give. Say, for example, LLMs can be used for good and bad purpose both. So when you want, let's say I wanted to understand for a negative kind of an situation or a bad purpose, okay, which I'm not supposed to. LLMs has their own guardrails, but prompt injection is something you can consider this as an virus and antivirus kind of a battle. So antivirus softwares try to introduce new features, whereas people try to create new malwares and viruses to attack them both. So this fight will be ongoing. Prompt injection is kind of evolving kind of an, or I would say ongoing battle, where you try to put guardrails at the same time you get new, and this is a rigorous testing which will be done. So from an industry perspective, we have a separate testing team which will be specifically dedicated for this kind of bias and as well as prompt injection testing techniques, so that you can put these kind of rules into your LLM application.
Thank
Okay, so
you.
that's
Thank you.
related. Yeah, yeah,
Thank you on that. Uh, yeah. Any other? Yeah, I don't think so. Yeah, similar to that. Just to close off from my side,
yeah.
I just want to ask one, like maybe a relevant. I feel like how these industries are now picking up this large language model or a generative, as we can see that there are quite number of challenges having their own data, all these things. How the industry is picking up, we can see that lots of research coming up, lots of open source products coming up. Many companies are releasing this. How the company as a adoption, so how they are picking up from your
Oh,
experience, or maybe when you are come across something.
okay. To be very honest, most industries necessarily, at least from my experience, they necessarily do not admit they are using generative AI in general, though some of proof of concepts is already going on. And especially from a return on investment perspective, it is mostly, as I said, a productivity enhancement tool. Okay, basically, we cannot show, our companies as of today hesitate to show in terms of revenue, in terms of new, as well as maybe savings as well. So that is something they hesitate to show. But mostly in every company or organizations, it is being used for productivity enhancement. Okay, so especially from IT and data science perspective, code generation is one of a common area because it saves a hell lot of time for the developers and data scientists. Okay, querying, especially in let's say traditional or monolithic systems, we still use SQL based on-premises data service. So SQL is very commonly used, and SQL is not something which every data scientist loves to work upon because it doesn't have the flexibility as Python as well. So that is where heavily these kind of tasks can be almost automated using LLMs, where you can generate the code and then uh, I basically use it. So this is one common use case where industries use text generation for all kind of content generation. It is very common, and summarization, especially, it's useful using RAG because you have lots and lots of company proprietary information in terms of PDFs, Word documents, PPTs, and some kind of images. So all this information can be stored in a vector database and retrieved using RAG architecture, and that is also a common use case. But from an adoption perspective, most companies, I would say, are in experimental phase, except for the tech giants. Rest everyone is on an exploration phase. Only they are preventing, or the only thing which is preventing is the bias and the responsible AI stuff, and basically the copyright of the information. Because you necessarily don't know who owns the content, whether the LLM or the data which is used to train the LLM or the company which has procured the service. So that copyright infringement is again a challenge as well.
Agree with it. Okay, as you can see that most of the students are from a master's and a bachelor students, mostly master students, where they are working adults. Some of them are going to look for a job. From the job perspective, you want to say something if you have anything, like how is the job scope or something that you
Yep.
feel like that could be a last one to close off. Others,
Yep.
please get ready to switch on your camera. We will take a photo after this with the Arockia. Please, yeah, that's for your. If you have anything you can say about the job perspective, Mr. Arakia, from your understanding, how you see the job market going to be.
Yeah. So from a job market perspective, I would say having a knowledge on at least one of the cloud platforms is highly essential, not necessarily only for LLM perspective. I'm talking in generally about data and data science related roles. I would personally recommend having a knowledge of one of the cloud platforms, be it Microsoft, Google, Oracle, or Amazon, AWS. Necessarily having at least one is highly essential because companies mostly use either one, or some companies use all the clouds depending upon the use cases. So depending on the use cases, they do choose the cloud platforms as well. Let's say a larger conglomerate, they try to use all the cloud platforms available. So having at least one knowledge of one cloud platform is highly critical for you. So it will be helpful as well because in real life scenarios, we'll always use cloud-based virtual devices only. Nothing will happen in your local machine. We generally, when I go to work, I never write a single line of code in my local machine. Everything happens in my virtual desktop because it helps in many ways. One is gives the right compute resource, and also data remains safe within the company premises as well. Okay. So from a job perspective, that is one thing which is crucial. Understanding if you want to explore more about the future job, how it goes, uh, understand LLMs. I would say use it, definitely use it. I won't say not to use it, but use it wisely. Use it for the right purpose. You can use it for either way, but use it wisely. Don't abuse it, but understand the nitty-gritties of using an LLM. Okay, as you use, you will get to understand what kind of prompts generate what kind of outputs. This is very critical for a job as well. Okay, so it is like Google search. If you use the right keywords, you will get the right result. If you give the right, if you ask the right question, you will get the right answer. Otherwise, LLMs don't answer properly. Okay, so use as much as possible. Understand the right combination of words which can be used to get the correct output. Okay, because LLMs cannot read your mind. It can only understand what you give as an input.
I can see that problem sometimes when I do a prompt. I'll be thinking something else comes up. Thank you very much, Mr. Arockia. I really appreciate it for spending your weekend Sunday with us. And our students, I believe, would have benefited a lot from the discussion. And you have summarized quite a number of things where you started with the generative AI and LLM, and even you talk about some AI, and then you talk about word embedding, LLM capabilities, and then we talk about the conversational AI, document AI, and I'm interested to do more research on this RAG. RAG, we can see that is popping up a lot at the moment. And lastly, I'll touch up this multimedia. That's the interesting part now. Again, putting of the videos and audios is also trending things that we can see from here. We have benefited quite a number of things from your talk that will give us to take a lead from here. Really appreciate it. Can you please everyone give a round of applause for our guest speaker, Mr. Arockia?